Hello everyone, I am presenting the Chaos Engineering project. The aim of this project is to evaluate the performance of microservice architectures with respect to resilience and efficiency. First, I will give some background on the topic and the requirements posed. Microservices are an emerging architectural approach within which a single software system is broken into many independent modules. The distributed nature of these systems enables a new testing method called chaos engineering, which is a discipline to test the robustness of a system against troublesome circumstances, such as failures of server nodes, etc. The aim of the project implementation was to build a very simple application based on the microservices architecture and deploy it with containers and the container orchestration tool Kubernetes that contribute to the resilience and efficiency of microservices. Here, the actual theme of the website is not important. It will serve as a sample system on which chaos experiments will be conducted to test its robustness. So the sample application that was built is a company review website where employees can review the companies they work at or post their salaries. It is designated to be a simple CRUD website, so it can take user input, store information, and display it in an arbitrary way. So the website consists of 3 tabs displaying the compensation information, the reviews, and a third companies tab that shows simple statistics for every company, such as the average compensation. And users can contribute by filling out a simple form. And the new information will be displayed on the relevant pages. And the same thing goes for the reviews. Next, I would like to shift the focus on the underlying architecture. It consists of 3 microservices, each handling a different functionality. There is a compensation service handling the salaries and a review service for the reviews. And these services are connected to a separate database storing the user inputs. And the company info service takes care of the company statistics and needs to request information from the other 2 services in order to return a response to the client or to the front end. These services are containerized and deployed on a Kubernetes cluster, which can be seen here in the Kubernetes dashboard. So in this case, we have 3 replicas for the compensation service, 1 pod or replica for the company info service, and 1 for the review service, as well as 1 replica for the ingress controller that is forwarding the request to the other services. Now I would like to demonstrate a sample chaos experiment. These are conducted with the tool Chaos Mesh, which is open source and installed on the Kubernetes cluster. For the test, a text file or a YAML file needs to be configured. It mainly consists of the targeted service, in this case a compensation service, and of the amount of instances that are targeted. In this case, we will target 1 first. And this value here can be set to a certain percentage or all in order to kill all the available pods for a specific service in the cluster. Moreover, it is possible to schedule chaos experiments, so they can be repeated every 2 minutes, for example. And the duration can be also set, while for a pod kill, it is not necessary to set a duration because it just kills the pod, so it's only a single action. But other experiments, such as network delays, can have a certain direct duration attached to them. To start the test, we will execute a command in the Kubernetes command line interface that applies the configured file to the cluster. The test and the status can be tracked in the Chaos Mesh dashboard. And the status of the pods can also be seen in the Kubernetes dashboard. In this case, this pod was targeted and was restarted, or rather replaced. Thus, it is more recent than the rest. When targeting one replica out of 3 for the compensation service, the load is redirected to other replicas and the service does not experience any downtime, as it can be seen here. Here, one advantage of microservice becomes evident. Individual, more critical services can be scaled up more and are harder to break as a result. Next, we will run a chaos experiment where all pods of the compensation service are targeted. And we see that the availability of the website is affected. Moreover, because the compensation service is defined as a critical service, meaning that other services are dependent on it, such as the company info service, we see that this service is down as well. However, at the same time, we can see that the review service is still available. Here, another advantage of microservices becomes evident. The operational independency of services enables fault isolation, meaning that the failure of a single service does not affect the availability of the entire website. Additionally, due to the efficiency of containers and container orchestration mechanisms such as Kubernetes, the failed pods are replaced automatically and almost instantly. This can be tracked here in the Kubernetes dashboard.